So I hope you took a minute to try and draw this one out yourself and see how much you can label. I was going to try to draw a plane and antenna, but I kind of gave up on that. Even my stick figures weren't turning out so good tonight. So a plane is now P-L-A-N-E, better than a picture. And of course, I can find the missing side y using Pythagorean theorem. The height of the plane doesn't change, so that dy dt is 0. Of course, I would measure the plane's distance from the antenna, shortest distance, once the plane is over here. And that is changing at a rate of 240 miles per hour. So now I'm ready to take the derivative. So hopefully when you plugged and chugged, you got 300 miles per hour. Okay, see if you can set up the next one and give it a shot. Okay, so I drew my baseball diamond. It's 90 all the way around. But on this particular problem, I know that my player is 30 feet from third base, and he's been running from second. So that distance right there is 30. So now I have a right triangle, and I can find y. Remember, this time I made y the hypotenuse, so I end up getting 30 square root of 10. So now, a little trick on this one. Since I'm looking at what rate the player's distance from home plate is changing, this speed of 28 feet per second is towards home plate instead of away. So I'm going to represent it, or I need to represent it with a negative 28, because I'm actually getting closer to home plate, not farther away. All right, so now I'm going to take the derivative. Notice that I simply plugged in the 90 as a constant. And hopefully when you plug and chug, you get an answer that looks just like mine. And again, since he's getting closer to home plate, I expect this to be a negative number, so I was not surprised by that. Try to set up the next one, and then peek and see what I did. Okay, so now make sure you read this one carefully. This time he's 30 feet from second, which means he's 60 feet from first. So I'm drawing my triangle. So remember again, my distance from home to first is 90, and so now I can use Pythagorean theorem, get my hypotenuse, which is 30 squared of 13. And remember, there's no distance changing along the 90, but this distance is changing. He's getting farther and farther away, and since he's getting farther away from home plate, this time that change will be a positive. So I'm going to take my derivative. So hopefully your derivative looks like that. And now I'm ready to plug and chug in numbers. So remember, this term is going to turn into 0. And when I divide both sides by this coefficient, I get dz dt by itself. And then this simplifies to 56 over square root of 13, and that would be feet per second. Hopefully you were able to plug and chug and get this answer all by yourself. See if you can set up the next one. Get the picture set up at least. Okay, so for the lamppost problems, we're going to start with this basic picture. And I know that the lamppost was 15 feet and the man was 6. And we're going to use similar triangles on this. So I'm going to call this little triangle base X and the big triangle base Y. And since that whole distance is y, then this distance right here is y minus x. Okay, so I had a change of heart, and I'm going to switch how I label these. I'm going to call this distance between the guy and the light post x, and the distance from the light post to the end of his shadow is y. So this remaining distance would be the y minus x. It'll make it a little bit easier. Okay, so then I'm going to set up my similar triangles. So big triangle, the left side is 15. I'm going to run out of time. I'm just going to pause this and go to the next video.